We will now look at the relationships between the bond price and bond characteristics. In order to work through this section, we will use Exhibit 1 from the curriculum. The first effect that we'll talk about is the inverse effect. This says that there is an inverse relationship between the price of a bond and the market discount rate. And let's look at that over here. Take bond B, the coupon rate is 20%, the price is at 20%, so this is the market discount rate. We initially have a par value bond because the discount rate and the coupon rate are equal. Now what happens if the market rate or the discount rate comes down by 1%, so the rate comes down to 19%. When the rate is down, notice that the price is up. So from 100 it goes up to 104.339. So rate is down, price is up. What if the rate increases to 21%? This is the market interest rate. Coupon rate is still 20%. When the rate goes up, then the price comes down. So there is an inverse relationship between the market rate and the price of the bond. This is called the inverse effect. On the next slide, we will draw a graph depicting this effect. Next, we come to the convexity effect. Again, let's consider bond B. Notice that when the market rate goes down by 1%, so the market rate goes from 20 to 19, the bond price increases by 4.34%. But when the market rate goes up by 1% to 21%, then the decrease in price is 4.05%. This decrease is less than the increase, and the difference leads to what is called the convexity effect. Again, I will show this graphically on the next slide. Then we come to the coupon effect. If we hold maturity constant and change the coupon rate, look at what happens. With a lower coupon rate, the impact of a change in interest rate is more. So notice that a 1% change in interest rate has an impact of 4.95 and 4.6, whereas for the bond which has a higher coupon rate, the impact is lower. It is 4.09 and 3.83. And finally, let's get to the maturity effect. Here, if you take bonds with the same coupon rate, so let's pick A, D and G. The difference is in maturity. So bond A has a maturity of 10 years, B 20 and D is 20 and G 30. When bonds have a longer maturity, the impact of a change in interest rate is greater. So here with bond G, the impact is 5.3 and 4.8 relative to bond A, where the impact is 4.9 and 4.6. Let us look at the inverse effect and convexity effect graphically. If we plot the price of a bond relative to the market interest rate, we will have a curve which looks like this. And let's put in numbers for bond B. With bond B, the coupon rate is 20% and the maturity is 10 years. Let's say that this represents the par value. If the market interest rate is 20%, then the value of this bond is 100. We noticed that when the interest rate came down to 19, then the price of the bond was higher. So then the price of the bond was 104.339. And when the interest rate increased to 21%, that's this point over here, then the price of the bond came down. So that is the inverse effect. And specifically, the bond price came down to 95.946. What about the convexity effect? For the same coupon rate and time to maturity, the percentage price change is greater when the market discount rate goes down than when it goes up. And that is visually depicted over here. When the market rate goes down by 1%, the price goes up by 4.339%. But when the market rate increases by 1%, then the price falls by only 4.05%. So visually you can also see that the drop in price when the rate increases is less compared to the increase in price when the rate decreases. And that leads to a convex shape. Convex when we view the graph from the origin. And this sort of a shape is called a convex shape, and this feature is called convexity. Coupon effect and maturity effect. I've already talked about this earlier, but for completeness, I am giving the full definition from the curriculum. This is the coupon effect. For the same time to maturity, a lower coupon bond has a greater price change than a higher coupon bond when their market discount rates change by the same amount. Another way of putting this is that low coupon bonds are more sensitive to interest rates. And then the maturity effect. For the same coupon rate, a longer term bond has a greater percentage price change than a shorter term bond when their market discount rates change by the same amount. So this is saying that longer term bonds or longer maturity bonds are more sensitive to interest rates. That is the maturity effect. Now let's work through example 3 in the curriculum. We are given several bonds, the coupon rates, time to maturity, and the YTM, which is the same for all bonds. Based on the relationships between bond prices and bond characteristics, which bond will go up in price the most on a percentage basis if all yields go down from 5% to 4.9%. The greatest impact will be on the bonds which have high time to maturity and a low coupon rate. So the answer to 1 is D. Which bond will go down in price the least on a percentage basis if the yield goes up? The least impact would be on a bond which has a low time to maturity and a high coupon rate. So here the answer is C. Constant yield trajectory. This is exhibit 3 from the curriculum, and what this is showing us is that a premium bond over time will come in value down to par. So this is the par value of 100. If the yield stays the same, the value of the premium bond will come down, and this is called pull to par. If we have a discount bond, initially the price of the discount bond will be less than par, but over time, even if there is no change in the yield, the value of the bond will increase until it gets to par value at maturity. If you want, you can look at all the numbers presented. So if the yield is 4% and here are the characteristics of the bond, you can actually come up with all these prices and plot this picture for yourself. Pricing bonds with spot rates. Spot rates are yields to maturity on zero coupon bonds maturing at the date of each cash flow. Bond price or value determined using the spot rates is sometimes referred to as the bond's no arbitrage value. If a bond's price differs from its no arbitrage value, an arbitrage opportunity exists in the absence of transaction costs. Let us make sure we understand the concept of a spot rate, and we'll understand this by looking at an example from the curriculum. A 1-year spot rate is 2%. This means that if there is a cash flow at the end of 1 year and no cash flow in between, this cash flow should be discounted at 2%. 2-year spot rate is 3%. This means that if there is a cash flow at the end of 2 years and nothing in between, that cash flow should be discounted at 3%. We are given the spot rates. We are given the 1-year spot rate, the 2-year spot rate, and the 3-year spot rate. And the question is, what is the price of a 3-year bond that makes a 5% annual coupon? Let's take a par value of 100. So at the end of year 3, we have 100. The coupon payment is 5%, so that will be 5, 5, and 5. Discounting with spot rates means that we take each individual cash flow and discount at the appropriate spot rate. So this cash flow will be discounted at 2%. The second cash flow will be discounted at 3%, and this third cash flow of 105 will be discounted at 4%. We calculate these three numbers and add those numbers. The answer that we get is the no arbitrage value. And if we actually do the calculations, what we get is 102.960. Now let's work through example 4. Calculate the price per 100 par and YTM for a 4-year 3% annual coupon payment bond given the following two sequences of spot rates. So we need to come up with two values, one based on this sequence of spot rates and another based on this sequence of spot rates. The first thing to do is recognize the cash flows associated with the bond. This is a 4-year bond. So we will have 4 cash flows, and those cash flows based on $100 par would be 3, 3, 3, and 103. This number, the first 3 is discounted at 0.39%, the second is discounted at 1.4%, this is discounted at 2.5%, and this is discounted at 3.6%. Come up with these numbers, add them up, and what you should get is 98.104. And then we are asked to calculate the YTM also. For the YTM, you can use your financial calculator. So plug in present value is equal to minus 98.104. The number of periods is equal to 4. Interest rate is what you are going to calculate. That's going to be the YTM. The payment is equal to 3 and the future value is equal to 100. When you plug in the numbers, what you should get is 3.516. This is the yield to maturity. The curriculum shows the long-winded formula, but if you get something like this on the exam, I want you to use the financial calculator. You can use these set of rates, and when you do the calculations, you will again get 98.104, which means that the YTM is the same. This example demonstrates that two very different sequences of spot rates can result in the same bond price and yield to maturity. And I quoted that from the curriculum.